Hello guys, welcome back to BerTronix TV. Let's talk about the basis functions. This is the second video for our signals and systems. I will introduce the cosine and sine as our basis functions. First, let's define the basis functions. These are the building blocks for creating more complex functions. These are set of n standard functions to estimate another functions. So let's begin with the basis colors as our intuitive example. This is the color red, green, and blue. Now guys, to create more colors, we need to have the combinations of these three basis colors. It depends on the relative intensity of red, green, and blue to cause a specific color to be displayed. In computer system, we have the RGB functions. Each of the color has 8 bits or 256 level of intensity, and their combination produce any other colors. Let's have our table as our example, and we have of course the red, green, and blue as our first color. In here, you will see the red stands on its own without any need for green and blue value. Green does not need any combination of red and blue, and it also stands on its own. Likewise, blue stands on its own that does not need combination of green and red. Now let's have violet. It needs 155 of red, 38 of green, and 182 of blue to produce this color. To obtain brown, we need 150 of red, 75 of green, and 0 of blue. To produce cyan, we need 0 of red, 255 of green, and 255 of blue. For magenta, we need 255 of red, 0 of green, and 255 of blue. For white, we need the 255 of red, green, and blue. And for black, we have 0 of red, green, and blue, or it's said to be the absence of colors. So let us make a little summary. Red cannot be represented by a combination of green and blue. So as we cannot represent green by combination of red and some blue. I cannot also represent blue by a combination of some red and some green. We can say that RGB are independent to each other. They are called the basis colors. Now let's have the basis vector. Like the basis colors, RGB, the basis vectors are independent of each other. Say, for example, in this illustration, we have the basis vector Z. basis vector y, and the basis vector x. You will see in here that vector z cannot be represented by vector x and y. Vector x cannot be represented by vector y and z, as well as vector y cannot be represented by x and z. But any vector like example vector A can be represented by vector x, y, and z and their corresponding coefficients, and another example vector B represented by x, y, and z with their coefficients. You will also see that basis vectors have exactly 90 degrees displacement to each other, and we say these basis vectors are orthogonal to each other. So, what is the basis functions? Like the basis colors and basis vectors, the basis functions are independent to each other and form an orthogonal relationship. Examples are cosine and sine functions. We will heavily use these two functions in almost all the signal approximations. Here you can see in the illustration, the cosine and sine has an orthogonal relationship. With that, sine theta cannot be represented by any combination of cosine function, and cosine theta cannot be represented by any combination of sine function as well. But if we take any point on the plane, it can be represented by any combination of sine and cosine. Let's say we have point xy. It can be represented by p or point r cosine theta and r sine theta. R, or distance of point from the origin, can be calculated by square root of the sum of the squared of the r cosine theta and sine theta. Angle of displacement theta can be obtained by inverse tangent of the ratio of r sine theta with r cosine theta. So let's have the summary and our takeaway. We have the basis colors RGB independent of each other. We can produce any other color through their combination. We have our basis vectors, for example x, y, z. They are independent to each other. They are orthogonal or perpendicular to each other. And any other vectors can be represented by these basis vectors. Let us have our basis functions. Sine and cosine as our example. These are independent to each other, form an orthogonal relationship, and any signal can be represented by combination of sine and cosine. So that's it guys for our basis functions. Again, thank you for watching again on BerTronix TV.